Okay, before we start, this, the bugs that I'm presenting were found in private warranty programs, so I won't be able to disclose the name of the company, but don't worry, I will discuss the bugs with detail, so don't worry about it. As you may have noticed, eu não falo português, desculpe, but I've been in Brazil before, as you also may have noticed. I know some basic phrases to survive, like uma cerveja, por favor. Okay, so I'm from Ecuador. I'm a web developer and ethical hacker. I work mostly with Python on the backend. I currently work at PHTalks as a core developer. And from time to time, I also do bug bounty. I love open source software. I have contributed to several projects with code and also reporting vulnerabilities to open source projects like KickPython, Django, OAuth, Sentry, NeoBeam, and of course, PHTalks itself as part of my job. You can find me on the internet as STSEWD. There is a link to my blog post, where I publish things related to security and software development. Now, let's talk about the target. This is a general description of the target. Let's say the target collects some information about GitHub repositories and processes this information, and it acts like a CI service. And one of these features that this service provides is that it allows to generating SVG graphs dynamically from this information. And what I found was the SVG graph included paths from the repository without being escaped. So I was able to inject anything that I wanted in the SVG graphs. And if you're not familiar with SVG graphs, this is one. It's basically XML. And this is how it is rendered in the browser. We have our nice blue square. And SVG graphs can also be a script, and we can use JavaScript for that. So we have our classic alert there. And if we render this in the browser, we have our classic alert there, the pop-up. And so I have the point of injection. Now I need to inject a payload into that. And there was some restrictions about the payload. The payload needed to be a valid Python, a valid path to a valid Python file name. And the project also needed to be a valid Python application. So if you wanted to inject this payload as a path, it will be injected like this. We have the first section, will be a directory, and then we have the path separator, will be the slash from the closing tag, will be the path separator, and the rest will be the file name. So this is how it will look like, the payload that I wanted to inject. In the file system, it will look like this. Like you can see, there are several init.py files that's required by Python. So it's needed to be a valid Python application. And of course, we have there the payload that will be rendered in the SVG. And of course, I didn't create all these files manually. I created a Python script for that, releasing. So I have everything in place, the point of injection and the payload. So it was time to exploit the vulnerability. And for that, I loaded the SVG graph with the payload, and what I saw the graph, but I didn't saw the alert. Then I checked the source code, and the script was there. So what's going on? What is the payload? What is the alert? Who stole it? So then I checked the console of the browser, and I saw this big error message there that says the script violates some policy. So it's time to explain what CSP is. CSP, Control Security Policy, or CSP, is a feature that helps to prevent, minimize the risk of some threats, like cross-site scripting. And this is done by controlling which resources a document is allowed to load. And how this works by using the Control Security Policy header that is sent to the server, by the server to the client, to the browser. And this header has a set of rules that the browser checks to see if resources, what type of resources are allowed to load. And the syntax looks like this. We have the name of the header, of course, then colon, and then the header can have several directives, and each directive is separated by a colon, semicolon, and each directive can have values that are separated by values, by space, sorry. We have some common directives, like we have default source that allow us to define some default values to some of the other directives. We have the script source directive that allow us to control which sources can be used as scripts, style source, which sources can use as styles, and so on. And the way I see it, we have two ways of preventing cross-site scripting attacks using a CSP policy. One is using a list of allowed resources, and the other one is using a nonce. Spoiler alert, using a list of resources is not the best way to preventing cross-site scripting. There are so many ways to bypass that. Using a nonce is more secure. I want to show you some examples, but first I want to tell you that there is actually a third way of preventing cross-site scripting attacks with CSP. And just don't use JavaScript. But we live in the future, and to load a simple static page, we need to download gigabytes of JavaScript, so that isn't possible. This is an example of the policy using a list of our resources. We have the name of the header, we have the directive, script source, and then we have a couple of keywords. For example, we have the keyword self that tells the browser to load all the documents from the same origin are allowed. We have the same line that tells the browser to allow inline scripts, because by default they aren't. We can also allow all files from a specific domain. We can even use wildcards in the subdomain. We can also tell the browser to allow a specific file name from an external domain, and even we can use hashes that tells the browser that the content of the scripts that matches the hash is allowed. So we have several ways to allow scripts. And this is the case of using a nonce. We have the same, the header, the script source directive, and we also have the nonce keyword this time. And we have the nonce keyword and then a hyphen, and then a random value that should change on each response. And this is the way it works. When the browser finds the nonce, it will check all the script tags and check that the script tag has a nonce attribute, and the value of the attribute needs to match the value that was given in the header. And only if that matches, it will allow that script to run. Now let's go back to the big error message that we got. Hopefully it's not scary anymore, that we know some basics of CSP. And what this is telling me is that I was injecting an inline script, and the policy wasn't allowing that. So what does the policy allow? And for that, we can check the targets policy by inspecting the response headers, and we can find something like this. The target was allowing scripts from the same domain, that self. It was allowing some hashes, and it was also allowing some external libraries from this CDN. Now, like I say, there are several ways to bypass CSP policy. So at the end, I will leave you a lot of links that you can learn about it. But the things that I tried in this target were the following. I tried to see if I could allot a JavaScript file to the target, so I could use it on the same, since it was allowed since it was allowed to include the scripts from the same origin, I could use that, but I wasn't able to find anything. I also tried to find endpoints that could use return JSON-P response. That's also a very popular way of bypassing CSP, but I didn't find anything. And even I tried to find ways to change the headers, but I wasn't able to find that. But then I remembered that some time ago, I found a very critical vulnerability in the target, open redirect. No, that's not critical, and as you may know, that's it's not always considered in bug bounty programs. That's why I didn't report that before, but I put it in some corner of my mind in case it came handy in the future. So I found that the target have an endpoint like this. If we went to target.com/redirect/homepage, we will get redirected to app.target.com/homepage. And what I found was the slash wasn't required. We could put anything after redirect, and that will be appended to the app.target.com subdomain. So with that in mind, I could just use something like this, redirect.example.com, and that will get redirected to app.target.com.example.com. And that's at the end. That's a subdomain of the example.com domain. That's our external domain. So with this, I was able to use this to redirect to any external domain. You may be thinking that I could just use this in my payload, since the first redirect is on the same origin, so it would be allowed. But the answer is nope, because browsers check each redirect that needs to be allowed by the policy. So the first resource is allowed, but then the second redirect is not, so it's blocked by the policy. But if we take a closer look to the specification of CSP, there is a section that says this about path and redirects. And basically says that when there is a redirect, the browser, for avoid leaking information cross origin, ignores the path. So every time that there is a redirect, it only checks the domain and protocol is in the policy. And the path doesn't matter if it's allowed by the policy or not. And this is only when there is a redirect. Let's see an example. Here we have a policy for a domain that is called example.com, and we are allowing sources from the same origin, the self, and we are also allowing a file from the a.com domain. So if we try to load the specific file directly, it will be allowed, of course, because it's in the policy. But if we try to load a different file name, that won't be allowed because it's not in the policy. And then we have the case of redirects. And what happens is if we redirect to another domain that is not in the policy, obviously that's not going to work. In this case, if we try to redirect to bit.com, that won't be allowed. But then things get weird if we try to redirect to, that was below. Anyway, if we try to redirect to a.com domain with any file that is not in the policy, because another file.js is not only file.js, that will be allowed, because when there is a redirect, the browser will skip checking the path and only check the domain. So with that in mind, we could take a closer look to the policy of the target. And what we see is it's allowing to log resources from this external domain, that is a CDN. And this CDN is actually a public one. And what this means is that we can upload any file that we want to the domain. And how? We can use this public CDN in two ways. Uploading an npm package, or by serving any file from a GitHub repository. So it's really easy to use. We don't even need to create an npm package. We can just use a random GitHub repository to serve a file from there. So with this, I have everything in place. Oh, I thought so, because I have the open redirect that allow me to redirect to any external domain, and I could serve any file that I wanted from the public CDN. But there was a small problem, is that the open redirect that I found was adding a subdomain to the final target. So if I wanted to redirect to cdn.jsdeliver.net, I will actually get redirected to app.target.example.com.jsdeliver.net. And that's a problem, because I don't have control over the subdomains of the CDN, and most importantly, that subdomain is not in the list of all our resources. because when there is a redirect, we can change anything we want in the path, but the domain must be in the policy somewhere, and that domain is not. But then I remember the URLs can have a basic authentication part that is called user info. I'm not going to explain what that is now, but in short, URLs can have this form, and when the browser see a URL like this, it will ignore everything here and just redirect to that domain as normally. So with that in mind, I could use my open redirect this way. I could use to /redirect at cdn.jsdelivery.net, and that will redirect me to this domain, app.target.com, and add, and while the browser will interpret this as the user info part, that's basic out, so that will be ignored, and the rest will be the domain itself. So I have now everything in place because I have the open redirect that will allow me to redirect to any domain that I wanted without the subdomain part. So I have full control over that. And also have the, I could upload any file that I wanted to the public CDN. So the final payload will look something like this. I'm using the open redirect there since it's on the same origin that will be allowed. And then I will use it to redirect to the public CDN that is serving this malicious JavaScript file. And since this is a result from a redirect, that will be allowed by the policy because this domain is allowed by the policy. So it doesn't matter if the path is not. And this is the actual exploitation in place in the target. So I have to censor the domains there. But I know that you people like to see in live demos. Of course, I can't show you a live demo because the program is private, and also because the vulnerability is already fixed. But instead, I created a small website that was using the same restrictions that I have on the target, and there is a video for that. So this is no. I think I need to click. Okay, there it is. So that's the script that I wanted to inject, where we see the CSP policy is in place. So this wouldn't work. Like we see, we don't see the script being run, but if we check the console, we see the error. The script is being blocked by the policy. Then we have the second example. We're trying to load the malicious file directly from the CDN, and that also is using the same policy. There we have the content of the script, and that won't work as well because that file is not allowed by the policy. If we can see, it's blocked as well. And then we have the final example. We're using the open redirect to the same file. We have the same policy as before. And this time, the script will be run. So that's it. We see there are no errors. And if we check the network tab, we will see first is the page is loaded, and then there is a redirect to the final script. And I need to mention that this only works on Firefox. It doesn't work on Chrome. Why? I'll show you later. There is the same payload on Chrome and the same policy, and it doesn't work on Chrome. And this doesn't have to do anything with the CSP policy. As we see, there are no errors related to CSP. But if we reload the page and we check the network tab, we see that this script was blocked by Chrome because Chrome doesn't like loading resources that have the user info part, the part that was using to ignore the rest of the subdomain. So Chrome doesn't allow to load resources that have the part in the URL, so this only works on Firefox. But that was enough for me to report this to the program. So I reported this last year on July 27th. And I was awarded $1,500 monthly for that. And on September 6, they fixed the vulnerability. I say fix it in quotes because they only fixed the open redirect. They didn't fix injection. Why? I don't know. But anyway, so then the time passed by, and some months ago, I was reading the report again. I wanted to write a blog post about it, and I found the CSP policy was gone. That was the only thing that was stopping the vulnerability from being exploited. So I checked, tried to exploit it again, and it worked. And this time, it was really easy, just an inline script, because I didn't have any CSP policy in place anymore to try to bypass it. So that was easy money. I reported the same vulnerability again. This time, they actually increased the bounty table this year. So I reported the same vulnerability and got paid $2,500 this time for basically the same vulnerability. Now I'm going to do a quick bonus showing impact without executing JavaScript. In short, I found a store cross-site scripting vulnerability on a target, and the target was using nonce in the CSP policy, and it was really, really well implemented, so any chance to bypassing that was almost impossible. So I wasn't able to bypass that, but I still managed to show impact without running JavaScript. And I'm going to give you 3 quick examples how you can also do that. The most obvious one is you have control over the HTML page to inject anything. You can change things. Maybe you have some control over the CSS. Then you can change things around. That's the most obvious one. We can also deny blocking the user from accessing the page by redirecting again and again to the same page. Or we can redirect to another page, like a phishing one. And all of this is done using HTML tags. So this isn't like requiring anything to run JavaScript. And another way is that we can create a form with 2 hidden fields called email and password. And those fields will be hidden to the user. And we have some weird behavior from, well, it's not weird, it's like the default behavior from some password managers is that when they see a form with these fields, they will automatically fill the form with the credentials from the user without user interaction. So when a user clicks on the button, the form will be submitted to an external domain that will have the email and password leak. Now let's see this in action. Here, there. Here I have a password in the Chrome password manager, and there we have the form with the hidden fields. The CSP policy is not allowed in JavaScript. If we generate the form and the user doesn't see anything else, just the button, if he clicks, then we can see that the password and the username has been leaked to an external server. And that's the same password that is in the password manager. So several password managers do this by default. Chrome is, the Chrome one is one of those. So you can use that. So I attached all of those examples in my report. So they validated the report and was awarded $1,200 for that. Some conclusions and recommendation. If you are a developer, know that just because you have CSP in place, that doesn't mean that you are protected for all the attacks. CSP, just fix CSP, just an additional layer. Always fix the vulnerabilities that you have. And when you need to write a CSP policy, start with something very strict, disallow everything by default, and then allow things as you may need. And if you're using to allow scripts to run, it's really better just to use anons instead of using a list of allowed sources. But I know this isn't always like the case. We can't always like do this. Sometimes we need to make sections because reasons. But if you need to make sections, make them on the page that need them. Don't make these rules like global. And some recommendations for hackers is that don't let the CSP policy stop you from finding more ways to run JavaScript. There are so many ways to bypass this, and for that, you need to get familiar with ways to bypass that, and also get familiar with ways to generate impact without running JavaScript, because there might be ways that you won't be able to bypass CSP policy. But as we saw, still injecting HTML can be something that can compromise the security of the page. And also test your exploits with different browsers. Like we saw, there's sometimes it works only in one browser or just another one. And I've been telling you that you should learn all this stuff. And as promised, there is a link of resources that you can learn that help me to learn all of these things. There is the whole list of things, how to bypass CSP policies and how to show impact without running JavaScript. There is also the demo that I showed you in the videos. There is the code for the demo there. And there is a QR on the code, so you don't need to search in the pictures, just go to the presentation to the page there. That's all for me. Obrigado. So looks like that I have time for questions. I'll do my best to answer it if there are.
So yeah, once again, any questions, please raise your hand, and yeah, let's give it 10 more seconds.
5, 4.
Yeah. Okay, thank you so much. Thank you so much for the talk.
Question here. Alexander, we have a question here.
We actually have the question. And I'm bringing the microphone. Or you have one. Okay, good.
Hi there. Sorry I'm late for the question, but here I am again. Well, I'd like to know if you got in your resources any link which refers to practice for cross-site scripting, because I think even though I might know some of the concepts, I like to apply them with more effort in order to get the results I'd like to.
Yeah, there are probably many resources. I don't know them from memory, but I guess you can just Google them. But also, like in the demo that I showed you in my presentation, is interactive one. Like you can edit the payload and change things as you may need. So you can, I guess, you can use that as well. But yeah, there are like several sites that allow you to like show you some JavaScript, CSS, and HTML files separately, and they join you. I don't remember the names of those sites in my head, but you just can look for those. And also like I say, the repository with the demos, they are interactive, so you can also change the source code and practice there as well.
Thank you.
Thank you for the question. I guess that's it.
Okay.
Thank you once again.